welcome back. In this video, we're going to look at compound interest and some applications. So first of all, what is compound interest? It's the interest computed on the original principal as well as on any accumulated interest. So let's say you deposit $2,000 in an account at Orlando City Bank, which has a rate of 1.6%. We want to find the amount, A, of money in the account after 3 years, subject to interest compounded once a year. So in the last video, we talked about simple interest, and we're going to use that idea to calculate the amount of money we'll have after the 3 years. So our starting balance here is going to be $2,000. Okay. If you'll recall, we looked at a formula called the future value formula, which tells us the future value of the account, like how much will be in the account or how much you will owe after a certain time period. So, and that was A equals P times 1 plus R times T, right? And the rate is 1.6%, which if we turn that to a decimal, we're going to divide by 100 or slide the decimal back 2 places. So it's 0.016 and then times 1, right? It's rate times time. Time is 1 year. I don't really need to put the times 1 there, but that's really what it is. Okay, so just remember that that is there. And if you multiply this out, 2,000 times 1 plus 0.016, you end up with $2,032, okay? So that's year 1. We want to find out how much money is in the bank after 3 years. So you made $32 interest. So in year 2, my starting balance is now $2,032, okay? So I have my principal times my 1 plus my rate times my time, and again, time is 1. And you end up with $2,064.51. Okay, now that is really the same thing as if we had put our original principal, and this time we did the 1 plus 0.06 2 times. So to the second power, we would still get $2,064.51. So see, it's the interest is computed on the original principal as well as on any accumulated interest. And we've accumulated interest 2 times, right? At the end of the first year and then the end of the second year. So you can probably imagine what I'm going to do here in year 3. We know our starting balance is going to be $2,064.51. So that means that's P. And I'm going to multiply that again by 0.016 so that I have interest on what I've accumulated so far. And you end up with $2,097.54. Okay, now that is the same thing as doing $2,000, my original starting balance, times 1 plus 0.016 to the third power, because you're accumulating interest for 3 years in a row, and you still get $2,097.54. So there is a formula that we can use when we're dealing with simple interest, and that is so that we don't have to keep doing that over and over again. It would be very tedious if we, kept money in an account for 20 years, or you borrowed money for a period of 20 years and there was compound interest on it. Your table would be 20 rows long, right? So the formula is very handy. It's A equals P times 1 plus R to the T power. So again, A is just your future value. and P is your present value. And of course, T is time in years, and R is your rate, right? And you want to write it as a decimal. So what I'd like you to do is practice using that formula and plugging the numbers and see if you get $2,097.54. You should if you do it correctly. Okay, what happens when we compound interest more than once a year? We have what's called a compounding period, and it's going to be symbolized by the letter N. And N is just the period of time between two interest payments. Think of it as the number of times you're compounding. So if you were compounding annually, N would be 1 because there's only one period of time between the two interest payments, right? If you compound semi-annually, that means 2 times a year. Compounded quarterly means 4. You might also see like compounded monthly, and you can probably guess N would equal 12 for that because there's 12 months in a year. So we're going to tweak our formula that we wrote down above to a new formula when we are calculating the amount in an account for compound interest paid N times a year. So N could be any number of times a year, and that's going to be A equals P times 1 plus R divided by N to the N times T power. And again, N is just the number of compounding periods per year. Okay, so you deposit $7,500 in an account that has a rate of 1.2%. The interest is compounded monthly. Let's say you want to figure out how much you're going to have after 5 years. So we have our formula, and we know that we're looking for A. We know P is the principal or present value, so that's what you're depositing. That's $7,500, and then you have times 1 plus the rate. 1.2% is 0.012, and then over N. N is how many times you're compounding, so that would be 12 times since it's monthly, and then it's to the N, which again is 12, times T, and T is 5 years. So really what this is 7,500 times, let's figure out what 1 plus 0.012 divided by 12 is. Okay, I'll get rid of some of this stuff. So working inner to outer, right? We have first 0.012 divided by 12. And then I'm going to add 1 plus that number. Okay. So that gives me the inside. So inside the parentheses, I have 1.001. And then it's to the 12 times 5 or 60th power. So if you're using a calculator that doesn't know order of operations, you would want to take care of this part first. So you would do 1.001 to the 60th power, and then you're going to take that number and multiply it by the principal, which was 7,500. Okay, and again, I'm not going to round because we talked about in the last video how rounding can leave you with rounding error if you're not careful. So I'm just going to type in that number. Again, there are other calculators where you can just punch this whole expression in and get the answer. But for the sake of people who don't have those calculators, you would just do it step by step here. But you get the answer regardless. It's $7,963, and if I round that to the nearest cent, it would be 54 cents. So it's approximately $7,963.54. So that's how much money is in the account after 5 years, right? Now, what would be the interest? So to calculate the interest, it's just got to be the amount I have now minus what I put in the starting place, which was your principal. So that's just going to be $7,963.54 minus my starting amount, which was $7,500. And if I subtract those, I get 400 and let's see, that's 79.63, not 36. So that's going to be $463.54. Sometimes you'll have the option to compound continuously, which is where the compounding periods increase infinitely, pretty much. So instead of compounding monthly or daily, you can compound every trillionth of a second, for example. So when that happens, we have to use this number. It's called Euler's number. It's the letter E. And E really just stands for 1 plus 1 over n to the n power. So where we have our P principal times the expression, right? Remember the expression was like 1 plus r over n to the n times t. So we're just tweaking that portion of the formula. And in place of it, we would be putting this, but this actually just equals E, okay? So that, it's going to be e to the r times t power. So this is for continuous compounding. And e, if you want an approximation for it, you can go on a calculator and find. Most scientific calculators have the letter e there. Sorry, I apologize for my pen here. So you can go to a calculator and type in E. For a Desmos, you'd have to go to the keyboard, just put E. It's 2.71828, etc. It's irrational, it's just like pi. It's non-terminating, non-repeating. So it's approximately equal to 2.71828, blah, blah, blah. But we're actually going to use the letter E when we're calculating. So here, you decide to invest $8,000 for 6 years, and you have a choice between two accounts. The first pays 2.5% per year, compounded monthly. The second pays 2.49% per year, compounded continuously. Which is the better investment? All right, so you've got here your two different accounts. We'll call it account number 1. And for account number 1, this is the one where you're compounding monthly, so n equals 12. So we're going to have to use our formula for compound interest when we're compounding n number of times a year, which, if you'll recall, it's a equals p times 1 plus r over n to the nt power. So here I know my principal is $8,000, that's what you're investing, and then times 1 plus the rate as a decimal, 0.025, and then over n. If you're compounding monthly, n would be 12, and then it's to the 12 times t. T is in years, and years is 6. So for this one, we're just going to type it right into the calculator the way we see it. I've shown you how you can type it in pieces, so you are welcome to do that. It's going to be 8,000 times 1 plus, and then it's 0.025 divided by 12, and it's to the 12 times 6, or you can just type 72. And you get $9,293.22. Okay, so that's how much money we would make after 6 years if we are in that account that pays 2.5% per year and it's compounded monthly. What if we compound continuously? We'll call this account number 2. So for this one, we need to use the formula with the E in it for compound continuously. My principal, again, is the $8,000. And E, remember, just stands for an irrational number, 2.718, et cetera, et cetera. And then it's to the R times T. And my percentage here is 2.49%. As a decimal, it would be 0.0249. And then the time is still going to be 6. So now I'm just going to punch this in here. And I've got 8,000. To access the E button, Euler's number, I have to click the keyboard and hit the E and then hit the numbers again. And then it's the A to the B button for the exponent. And my exponent this time is going to be 0.0249 times 6. So I need to put that in parentheses. 0.0249 and then times 6. And you get 92.89 and then about 10 cents. So account number 1, where you're paying the interest paid is 2.5% per year compounded monthly, actually is the better deal, just by a little bit, by a couple dollars. Feel free to try the next two on your own. Again, if you have any questions, feel free to reach out. But that is the end of the video. I hope you all have a great rest of your day.